Okay, so this is the second day. Yesterday we covered a little bit of introduction, and we made an overview of EclerNet Manager hardware. And we have noticed that we started to have some problems here when we talk about the WP22 The End. So we will start from there, and we will follow to the second day plan. Which is talk about the software mainly. Okay, what tools do we have in MIMO? Mainly MIMO because it's the more complete device, and you can also control DuoNet and Bob. But once you understand and you get into the MIMO philosophy, the other ones are quite easy. I mean, there's no issue in that. So we'll cover the MIMO, which is the most complete device. So as we told, WP22 The End. WP22 The End is an interface, okay, a Dante interface. So it's not really an EclerNet Manager device, but as our Dante devices, our MIMO Dante devices are from EclerNet platform, it's worth just explaining here 22 The End because it's a good relation between them. So it's not an EclerNet device because there's nothing to control. Everything is controlled physically in the device. So you will find that we have two microphone inputs, two outputs. Okay, it can be configured into line or mic. You can add phantom, and you can transmit these two channels, input 1, okay, or input 2. So we have two Dante transmitters, which you can decide to send input 1 or both of them summed up. And on the other hand, in transmitter 2, you can choose to send input 2 or channel 1 and 2. Then we have two balanced outputs, XLR, or we have doubled outputs at the back of the unit as a neuroblock. Okay, just to show you, we can take off the metal covers from this slide to show you. Here are the switchers where to switch these choices. Okay, to select these choices, phantom or whatever is sent. You can find this information in the manual. There's no sense to cover the details here. Also here we have sensitivity. Okay, you can read. In fact, in the product there are some blank plates. So if you do not want the user to touch this, there's a blank cover with no hole here. Okay. Okay, so if we get to the example we did the other day, okay, you remember we had here the MIMO 72 The End, the DuoNet, PageNet to send messengers to each and every floor. We have 3 floors. Here there's a Dante receiver inside this amplifier. Okay. There's a receiver, but there's no transmitter, so you cannot transmit this signal onto the network. If we choose this, and it's more or less the same price, you can send whatever you get into this unit, into the WP22 The End, you can send it to the network, and can it be managed from the MIMO 72 if you want to be sent to the other floors. And you have 2 signals here, 2 independent signals, as well as the outputs. You have 2 independent outputs. So this is a mono amplifier. In this case, it's a ECA 120 high impedance. It's a mono, but you could add another amplifier to the other output and have 2 lines in this flow. Okay, so more flexibility. Okay, let's talk about 4040 CDN and 7272 DN. We have this balance local in audio inputs and outputs, okay, analog inputs and outputs, and we have 2 monitor ports, the same way as the MIMO 88. Okay, we have monitor ports here in the back, we have a jack on the front. We have 2 Dante ports, 2 Dante RJ45 ports, which are the primary and the secondary. Okay, so in my case of MIMO 4040, we have 32 channels going in and out. In the case of 7272, we've got 64 channels in and out. Okay, you can switch from redundant mode to switch mode, as we said yesterday. Okay, redundant mode, you can create 2 networks. So if one breaks down, the other one will cover without having any trouble. In switch mode, there's no redundancy, so you are using this to connect another device after this one. So you can daisy chain another MIMO, a remote, whatever you want. Okay, so I explain also, just in case you did not reach the signal correctly, about flexible routing. Okay, MIMO 4040 The End has a matrix inside of 40 channels, so everything by default is routed like this, 1-to-1. Okay, the same to the output ports. Okay, but what about 7272? We haven't got any matrix inside of 72 channels. We only got 64 channels, which are quite a lot. So how is routed by default? By default, we've got, as all these channels do not fit into the matrix, we have to divide them, and we've got 8 that are not connected. These 8, the digital ones. Okay, so we have got the first 8, which are the analog ones, and the 56 digital ones, the first ones. What about these ones? They are not used. Yes, we can use it because we've got the same for the outputs. Okay, so what about these channels? We cannot use them. Yes, we can use them because we've got the flexible routing feature, which allows to select which input port you want to route to each matrix channel. So you can decide to get analog input 1 to this, for example, this input A. At the same time, you can just double, so these are sent to both channels on the matrix, and so you can do whatever you want. And this is you can memorize this into a preset, so it can be recalled, and you can have different combinations of this routing depending on the scenario you are. Okay, and the same happens in the outputs. Okay, but here what's interesting also is that you can route 2 outputs to the same 2 outputs of the matrix to the same output port. And what will happen here? They will be all summed up. Okay, 2 or 3 or whatever you want. So, but you will not be able to decide in here the balance in between signals, but you can decide here the level of each signal. Okay, so if we follow up, we've got also 8 GPOs here. Remember, the only one that have got GPOs is MIMO 88, and also of the ones we covered already. So SG has no GPOs, not 88 SG, 1212 SG, no GPOs in there. Okay, 88 has GPOs, and also MIMO 4040 CDN and MIMO 7272 DN have got GPOs. Okay, GPIs, the RJ45 interface, this is for controlling purposes. You will need this connection to control it from EclerNet Manager or from a UCP, or to send commands through the network to the device. You will need to be connected. So there are two different network interfaces here. This one is for controlling, this one is for Dante. Okay. We've got here also a DB9, which is an RS232 interface, okay, which is the one that is used to control this device with TP-Net protocol for third-party integration. Okay, again, you cannot send commands to a serial device. Okay, just this RS232 is conceived to receive commands. These devices, 7272 and 4040 CDN, have an embedded UCP server. So up to now, we have said that there's a PC. A PC can act as a UCP server to provide UCPs, user control panels, to each and every client. A PC, a WP-Net Touch, and these two MIMOs integrate also a UCP server. Okay. And the remote controls can be, the digital ones can be 4kV, 8K, 12K, or WP-NetX. We will cover this in detail afterwards. It has got NTP synchronization as DuoNet player. So which devices have NTP synchronization? 4040 CDN, 7272 The End, and DuoNet. Okay. And it's AES67 compatible. Okay, talking about scalability. Okay, we've got a 7272 The End, and if we want to make an installation with this, okay, we connect the Dante signals onto the network, for example, and we've got some sources getting into the matrix. So, and we get out of the matrix in digital to a 64 zones installation. Okay, so here we will find all the amplifiers, the loudspeakers, the analog, digital to analog converters if they are needed, whatever. Okay, here we have got a bunch of bobs. Okay, so we'll have 64 zones here. Okay, so how we will control this? We will control it with the other RJ45 connection. If it's connected, we can provide the UCPs from this device to any client. Okay, WP-Net Touch, a browser, a smartphone with the app. What if you need more zones? Okay, it's the maximum 64 zones, as we've got a 64 by 64 matrix here inside. No, we can do a lot more zones. How? With this trick. Okay, this is for analog. So we've got a MIMO 8, kind of MIMO 820. Okay, we've got 20 outputs and 8 inputs because we doubled the inputs. So if we've got a 128 zones installation, okay, we will have the same sources connected to the 7272 The End, and we've got the control here, and we can add another one. So we can send 128 channels onto the installation. Okay, we'll have to make the corresponding UCPs. Let's put this in an example. If we've got an airport, okay, with many gates and different common areas, okay, think about it, maybe we have 117 sources. okay, but we've got 144 zones. So in this case, it's more or less the same number of sources than zones. But all of these sources need to be routed to all of these zones, okay? And the answer is no. Usually, if you are in gate A1, you don't want this message to be sent to gate E2, okay? Messages in A1 stay in A1, and maybe there are some common sources that you want to send the message to all of these in gates, okay, or part of them depending on where they are. So at first sight, what it is okay, I have 144 zones, so I get a matrix of 144 and by 144. This is not possible. Usually are 8, there are 128, 256, 512. So you will find a matrix like that, maybe. Or maybe there's no matrix like that, and you have to go to 512. Think about it, because it's not a very cost-effective way of designing. Okay, a big matrix like that, it can cost up to $30,000 or $35,000. Okay. Can we make it the other way around? Yes, because we don't want all the sources be routed to all the zones. So here we've got these gates that have to be routed to these gates. Okay. So the same in these cases. Okay, this takes care of this. See this 28. Oh, here there's a mistake. There are more sources than gates, but it's okay. You can understand. Okay, so what we really need is that these common sources, general mic, or a message player, or an emergency message, and get to each and every zone. This is quite important. So we will route these signals to each and every device, so can be routed to each and every zone. And the common areas can be covered by also the spare outputs we do have in these devices. So here we've got a lot of output ports left, so we can just route. So this is a more cost-effective way of designing a thing like that. Okay, obviously we will have to make all the controls, which will be depending on what you want to control. It can be quite a challenge. Okay, but it can be done. Okay, so what about CDN? So what's the difference of CDN? The CDN we have, it's made for conference purposes, and we've got auto mixing, feedback killer, and acoustic echo cancellation. Okay, acoustic echo cancellation is an algorithm that consumes a lot of DSP power. Okay, so when we are using AEC in MIMO 44 CDN, so we are using this algorithm, the size of the matrix is reduced. Let's see. We've got here the MIMO 4040 CDN, okay, and we've got here this ISE algorithm that runs in parallel of the matrix. So depending of the number of mics that are using and the AAC algorithm, okay, you got a bigger matrix or smaller. So if we got 0 channels in the AAC, so we are not using, we got a 40 by 40 matrix. If we are using just 1 channel of AAC, we've got 36 by 36 matrix here, okay? If we got 2 channels, 32 by 32, and up to 8 channels, which is the maximum number of channels that can manage our AAC algorithm, okay? We've got a matrix of 8 by 8, okay? So just to remember, 1 AAC channel reduces our matrix in 4 channels, okay? Let's see it. If you open your, don't do it now because you will get lost, but if you open your EclerNet manager, okay, you put a device, MIMO 4040 CDED, in this case it's the old 4040 The End conference, but as we told yesterday, it's exactly the same. You will see here this information. AC mix count, 0. Here we have no microphones used in the AAC algorithm, so we've got a matrix size of 40 by 40. 1, 36 by 36, 2, 3, 4, okay? Now, when we arrive to 7, as we see 16 channels here, we notice that here we've got 12, and there's no possibility of using this part of the matrix, okay? No outputs, no cross points, okay? And up to 8, as you see here, we've got the smallest matrix, 8 by 8, okay? So that means that we can only use analog channels if we are using 8 AAC mix. So this, remember, the AAC mix run in parallel of the matrix. So has the algorithm can be working for some conference room, and this can be working for background music purposes, okay? But then it has to be analog, because here there's no possibility of routing something that it's not analog in this slide. No, because we have flexible routing, as we showed. So I can assign whatever input port of the matrix of the device, okay? We can assign it to each and every channel of the matrix, okay? So here we can put digital input 1 or digital input 5, whatever we want, or the analog ones. And I say in the inputs, but in the same way, we can route whatever we want from the matrix output to the matrix output port. Okay, the matrix output channel to the matrix output port. Okay. Okay, so briefly, I will just introduce you to the acoustic echo cancelling algorithm, okay, that we have in MIMO 4040 CDN. It's got 4 AAC modules. This matrix can work independently, okay? And there are 4 rooms available, so we can independently make 4 algorithms like that to work in 4 different places. The total number of mix is 8, and that can be processed, okay? So if you got 4 rooms, maybe you can assign 2 in each and every room. If you have 2 rooms, you can assign 6 in one room and 2 in the other as a maximum, okay? Or if you want to make 2 mics in the first room and 2 in the second room, you can also decide that. two licenses are provided for free on demand. What means this? That from factory, there's no license provided, okay? You have to ask your distributor, or if you are a distributor, you have to ask us to get these licenses for free, okay, at no cost, but has to be asked for, okay? These two licenses means two mics, two microphones, okay? So the maximum number of licenses are 8, as we have 8 microphones at maximum. Okay, here's a diagram of a regular conference call. Okay, we have two sides, the near end and the far end. Okay, so the near end has its own microphone and its own loudspeaker. So this is processed into the MIMO 4040 CDN, okay, and is sent onto the transmission line, which can be a telephone line, a soft codec like what we are doing, like Zoom or TeamViewer, not TeamViewer, Teams, sorry, or whatever we have. And this is, okay, we talk here, this is sent, and it's reproduced from the by the loudspeaker in the far end. Okay, that's my partner listening to me. So you are now my far ends, and I'm my near end. Okay. So in case my partner speaks back, he will use his microphone, and this will be sent back and processed. Okay. And here is the acoustic echo cancellation. It's an echo cancellation. So when is this echo produced? When the loudspeaker, my loudspeaker, reproduces the voice of my partner, okay, and the microphone, my microphone, captures this noise, this sound, let's say, okay. So my speech gets onto loudspeaker, gets into the mic again, and it's sent back. So when this arrives here, it has done all this way around, so it arrives as an echo. Okay, we've got an echo. The same message delayed. This is quite annoying, and that's why it's so important to have acoustic echo cancellation. Okay, because then with acoustic echo cancellation, it processes this signal that is coming back and gets the signal from the signal. So takes away the signal from the signal that is sent to this loudspeaker. Okay, that's how it's processed. Okay. Okay, so let's see it briefly. Here you got the near end. In this case, we are using two microphones. Okay. In this case, we have selected two microphones. You see, we've got two microphones here. That's why I get a matrix of 32 by 32. And we have a local mix auto mixer. If we go here, we will get the different parameters. I don't want to just bore you with lots of technical things. Just you can see it in the manual. You can see the far end remotes. So the interesting thing, just for you to know, is that you will have here, okay, if you push here, it will appear the image. So you can just clearly relate which signal here, okay, let's say remote mic return. I don't not remember what's this. So you get here, and the remote mic return refers to this signal. Just to clear the concepts. It's an information tool. Okay, so it's quite useful. Okay, let's move on. VO, XTI, 2L, and XRI 2L. Okay, this is a video device, 4K, ultra high definition, HDMI over IP. Okay, so we have here the LAN port. Okay, it's low latency, 1 to 3 frames. It's point to point and multi-point to multi-point. We can create video walls up to 8 by 8 screens. It has an audio embedder. It's a KVM extension, okay, from here or here. And it has also RS-232 and IR extension. You can send also messages RS-232 to other devices. Okay, sorry. It is PoE as well. So it has an external PSU included, but if you want to use PoE from your switch, you can use it. So imagine we've got several sources, digital signage source, a Blu-ray, a camera, okay? And we've got maybe a room here with a projector and a conference. There's a conference there with one speaker, okay? And with his laptop connected. So it will be sent here for projecting. Maybe you have another room with another TV, and maybe you have a video wall on the hall, okay? So you can manage all this with a WP Touch, which is our touch screen, okay? And maybe you can connect here, for example, in this room, you can connect a mouse and a keyboard just to control this device. And maybe there's an event in the hall and you want to add another device. You can also add another computer and just control this computer, the second computer from here, okay? Okay, if you want, you can also connect to the network if you want, and if it's possible in these devices, connecting these devices to the network and controlling these devices from the WP Touch, okay? This is also possible, although we do not sell any cameras or any projectors. If these devices can be controlled from the network, it can be easily integrated into EclerNet platform. Okay. In the same way, we have got a converter, an RS-232 converter, to connect anything that works in RS-232. So we've got this device has a LAN connection, so a network connection, and translate these messages that arrive here into RS-232 for controlling, for example, a screen that accepts RS-232 messages. So you will be able also in this way to control the screen. Okay. Okay. So we did all this overview. Okay, just half an hour. So we must continue to the next ones. Okay, to software. Let's start with the software. You've got information and resources in the website. Okay, so there's a manual. There are manuals for each and every device, but in each manual of each and every device, you will find the hardware manual. If you want to know how to configure, let's say, DuoNet with the software, you've got to download the EclerNet Manager software, okay? There are text files as well. Everything about EclerNet Manager, you will find it under the audio tab, software, okay, and then you've got user manuals here tab. You will find the user manual, okay, this one. Okay, also the TPNet manual for all the devices. You will find it here. Under software tab, you will find the latest software and firmware. Remember that this is a package, okay, package that in there is the basic panels, controls library, legacy software and firmware table, okay, the software, and each and every firmware. Software and firmware match together. So each time you download the package, just store it in a place where you can recall it whenever you have to update a device or whatever. Okay. We've got also some examples and some projects. We've got this is quite new. The extra UCPs project. They've got many examples of UCP, so you can take advantage and you don't have to design them from scratch. Okay. We've got media as well. Here there are something like 11 videos. We will add some more in the next weeks. There's more than 1 hour, so you can spend your time watching some of these videos, okay? And also there are the webinars, so just you can take a look. There are some interesting things. Okay, so we've got here the software. Just let you know about what are the different things. Here we have the menu on the top side. We've got some buttons. This is the working mode, designed just to use everything, to change everything with no limits. In deploy mode, you can not change what critical things that may affect to the functionality of your devices. Okay, this is something that tells the manual. Explain this is just in deploy mode. You cannot change maybe the IP of a device. You cannot change some other things, because when you are in the deploy mode, you start the UCP server. So mainly the main features are blocked, so you cannot change some things. You will notice, because you will find that whenever you, for example, right-click on a device, some of the choices are in gray, so you cannot change the IP, for example. If you just click on design mode, you will be able to change it. So it's an instant change. Okay. Okay. Here you have, in this window, you have the tree of your devices that are in this project. Okay. Here are all the output channels that are in this project, and here are all the UCPs that are in this project. Okay. We've got an auxiliary window. We will see later on what you can see here, but it depends on the letter you have selected here. Devices, channels, online and in-use device list, and properties, okay? And here, when you double click, for example, here, it will appear the setup of your device, which is the one you have selected here, okay? So you select here in the tree, and you will see all the settings in the right window, okay? Okay, so what do we have here? Inputs. In the inputs tab of a matrix, of a MIMO, okay? We have the input sensitivity, the delay, parametric use, noise gate, compressor, level, and frequency shifter. That was very fast. Okay. We can repeat it again with the, as you see, this is a MIMO 88, and this is a MIMO 4040 CDN, but it's exactly the same layout of MIMO 4040 CDN or MIMO 7272. We've got the input tabs, so we've got sensitivity. Here you can, this is what is different, that here in the top, you can decide the flexible routing. You remember, you can decide, this is the first channel of the matrix. You can decide which port is assigned to this channel. So here you will be able to decide if you want analog input 1 or digital input 1 or whatever you want. Okay, this is the selection. The delay, the parametric EQ, the noise gate, the compressor, okay, the level, and the frequency shifter. So we have the same things that in MIMO 88, just the distribution is different, okay? And in MIMO 88, obviously you don't have flexible routing, so there's no, this choice is not in there, okay? Okay, so let's move on, okay? In the input, what do we have in the inputs? Sensitivity, so 0 dB for professional devices, minus 20 dB for domestic devices, and minus 40 dB for microphones, okay? And you've got a gain to just adjust between minus 10 and plus 10, so you can adjust the sensitivity here in bigger steps, and then fine tuning here, okay? And we've got a phantom of 42 volts, okay? If you push here, you activate the phantom. Here you decide if you are in mono mode or stereo mode. Delay. Well, delay is the input delay, just for milliseconds. You can decide if you want it to be shown in milliseconds, seconds, centimeters, or meters. Okay, parametric EQs. We've got 4 parametric EQs. So you can decide for each of one of them what to choose, if you want a parametric EQ or a low shelf or a high shelf, okay, different types. You got the frequency, 3 parameters, frequency, gain, and Q, in case you need both, 3 of them. And you've got also a graphical way of showing this, okay? Let me show you the graphical way. Let me add a device. This is in real time, let's say, okay? So here, okay, let's go in an input, okay, this input, and I want some parametric EQs, okay, here, parametric EQs, okay? So we've got 1 parametric EQ in input 1. If we go here, we can have this this graphical way, and we can just adjust whatever we want here directly, okay, which is more comfortable than just putting up the parameters here, okay? Okay, it's just this button here, so just try to remember. And what else? We've got a noise gate, okay? I will not get into this. A noise gate, you can find anywhere how it's defined. So are the regular parameters. There's no mystery in here. And the compressor the same way, okay? And if not, you can find a page in the manual defining what is an audio compressor and how it works, okay? We've got level here. The mute is 120 dBs attenuation. There's a phase inversion and the gain with a 18 headroom, okay, 18 dB headroom. And we've got a peak meter, pre-feather on the left side and post-feather on the right side, okay. And we've got a frequency shifter. This one maybe it's the most, is not so common in other devices. The frequency shifter, it's a tool to reduce the possibility of feedback loops, okay. So a loop, we all know what is a feedback loop, okay. A frequency is reproduced from the loudspeaker, it gets into the mic and it's amplified, and then you get this loop and it comes to a tone, okay. So what's about this? What's this tool about? This tool, what makes it displacing in frequency this signal. So we break this loop, because what the loudspeaker reproduces is not just exactly the same as it was, okay. This it's something that helps a lot to avoid feedback, but if you want to have feedback, you will have it, huh? And also just take into account that as you change frequency, you change tone. So it's okay for live and speech applications, but not for music applications, okay. It's not recommended for music applications, as you get out the music out of tone, okay, maybe the singer. Okay, about the outputs, you see that there is more or less the same things, okay. We've got a crossover and a limiter, okay. Here in the other layout, we've got the same things, okay, the crossover and the limiter. So here you will find a low pass filter and a high pass filter of several, several types: Butterworth, Bessel, Linkwitz, Riley, and you have a limiter which is a compressor to the maximum, let's say. So when you go over a threshold, everything is limited, okay. We move on, we go to the matrix. We've got here, we are in a MIMO 88, for example. We've got inputs in the left side, outputs on the top. So the signal goes like this, okay. This is inputs and outputs. Here we have the cross points, and here we have groups, okay. Here in the other layout, we have the same things. As you see, we've got a lot more groups, and of course, inputs and outputs, okay. Okay, let's look it up carefully. As we said, there are inputs and outputs. This is a cross point muted, so there's no signal route to this output, okay. From input 2 to output A6, there's nothing routed. Here is selected and it's at maximum volume, as you see. So input 5 is routed to output 6, and this one is the one that is selected. That basically means that here this level that shows here relates to this crosspoint that is selected, okay. And what's this? This is the stereo and mono and stereo mono selection. So, and let me show you this in the software directly, so it will be easier. Okay, let's do it with a small matrix, so it's easier to see. Okay, so we've got here a matrix, So if we choose to have this input in stereo mode and this output in stereo mode, okay, stereo mode, okay, we'll have the matrix like this. And I always recommend to, when you are in the matrix, you can change also if you want stereo or not from the matrix directly, okay? You see, now I deselected and input 1 and 2 are in mono mode. If I go here and I just select the stereo mode, they are in stereo, okay? Usually when you are in stereo mode, you want the matrix, these signals behave in the matrix tab as a stereo. So you have to always select this, always or 99% of the times, okay? For what? Because if you then select here, the other one will follow. So in this case, I route a stereo signal to an output which is stereo. So the left goes to the left and the right goes to the right. If I send then a stereo signal to an output 8, which is a monozone, I will send both signals to the output, okay? If I want to send a mono signal, which is input 8, to these outputs, okay, I will send the same signal to both channels, left and right, because I just to get sound from both of them. And if you route a mono signal to a mono output, okay, then it's one crosspoint, okay? Perfect, makes sense. What happens that, as you already seen, if I select, let's mute everything. If I select from here, stereo, by default, and here again, stereo, what happens is that, okay, no, let's do it the other way around. Matrix, input matrix. Okay, let's do it the other way here. Now I use input 8, 7, and 8 as a stereo, okay? You see, by default, the chain, they do not behave as stereo in the matrix, which is the symbol of the chain here. What happens? That when I route input 7 to output 7, okay, input 8 and output 8 do not follow. So I can route this to another place. So this is, it has a very few applications. So it's a usual mistake or something that we forgot, just to activate this, to make this behave in here, these inputs behave and outputs behave as a stereo in the matrix, okay? Okay, just a little trick to remember, okay? Just if you are here, if you have one symbol, just put the other one. Okay, groups. Groups is a tool to group and synchronize matrix control, okay? So let me show you, because we've got several types: mute group, volume group, mute volume group, and parallel output group. So I will show you the last two, okay, and you will understand directly the other ones, okay? Sorry. So let's mute everything again. If I decide mute and volume group, okay, you can just click wherever you want in the matrix, and let's put here, okay. So we have a volume group, so all of the selected cross points and input and output level will be the same. 0, 100 will follow. If I use this, if I change this, everyone follows this. If I change each and every cross point that is in the group, okay, if it's changed, the other ones follow. They are solidary, okay. Okay, so the same for the mute. Okay, this is a volume and mute group, so you can understand what is a mute group. Just only refers to mute, and a volume group only refers to volumes. Okay. So now, what is a parallel output group? Okay, this is something when you want a signal to mix an output. Okay. Let's say output 1 and you want to output 3 behave the same, to have the same mix. Okay, here output 1, here output 2. The whole column is selected. Why? Because now output 1 and output 3 will behave the same and will have the same mix. Okay, you see? And what for? Because this is perfect for combined rooms. These rooms that you have, maybe it's very common in hotels. You have two rooms which are next to each other, and you have a folding wall. And this folding wall, when it's in place, okay, these rooms work independently. But when you unfold this wall, you want these rooms to be combined and just act as one single room. So we can activate this parallel output group feature whenever they are both rooms together, okay, and deactivate it when they are independent. Or also if we have a stereo signal, okay, and we have subwoofers. So here we have a stereo output, okay, output 7 and 8, and let's imagine that we want, and now I change this, we want, we have the subwoofer of this zone in output 6, so we want that sounds always the same, okay. So output 8 follows output 7 because they are in stereo mode, okay. Output 6 follows output 7 because I decided here in parallel output groups, okay. So it's a way of having the subwoofers. Okay, let's talk about events and presets. We have here, as you see, a button which is the events button. It opens up a window in the bottom, and here we have the presets. Okay, if you push here, you will get the 99 presets list. Okay, in the other layout, the most recent one, you have here the button and here the presets. Okay, so what are events? Events is a small program routine that is activated when some condition, source, or trigger is accomplished. Basically, you get a stimulus that is related to an event, and this event will make an action after this stimulus, okay, after this trigger. There are different types. You can see it: analog, digital simple, digital compound, digital delay, and time scheduler. Okay, and the target or actions, okay, are here, and depending on the type of event, you will have some actions or another ones. Let's see it in a graphical ways for better understanding. Okay. Sorry. Events. We have Here in the left side, we have the stimulus, the sources, okay? This is the type of event. And here in the right side, we have the actions. So the first type of event is an analog event. So it's in the type of source is a GPI, which is maybe a potentiometer, and virtual, which may be a fader or a rotary mix or whatever in a screen, okay? So this type of sources can have a whole range of values between 0 and 100%. It can be at 50%, 25, 37, whatever. So the whole range of values can be selected from these sources. So what are the actions that this can make? Okay, so this logically, you want to turn up or down volume, okay? Where? In the input side or in the output side or in the matrix, so inside the matrix, in a cross point, okay? So these are the type of actions that you can make with an analog event. A digital event, there's not the whole range of values, just two values, 0 or 100. That's a digital one, okay? That's what it means. It's a digital concept, okay? 0, 1, active, no active, whatever you want to call it. So which type of sources do we have? We have GPIs, for example, a button or a relay or a switch. We have a virtual, which will be buttons in a screen. Pager, which are buttons in a pager, okay? In a name page, we can assign an event to a button in the paging station. We have also the Docker event. We haven't seen Docker yet, but we can. This is a new feature that we have the symbol there. New feature from version 6 software. Mainly, you can decide to make an action when a threshold is overpassed. Okay, so in a Docker, we will see Dockers, and then you will fully understand what I mean. But when some signal gets over a reference level, you can make some kind of action, okay? Recalling a preset, whatever. And event out. Event out means that you can just concatenate events. So the event, if I create event 1, okay, which is when GPI is active, make something. You can create an event 2 that basically the trigger will be when event 1 is activated, then make event 2. So you can concatenate events one after the other. These are the sources of a digital event. And what can we make a digital event with a digital event? Basically, we can decide to mute an input, an output, or some crosspoint in the matrix. We can decide to recall a preset. We can decide to activate a GPO, okay? And that's for the matrices that have GPO. Remember, MIMO 88 and 4040 CDN, 7272 The End. And in this case, these last two actions refer when EclerNet Manager is being used as is running in a PC. Okay, why? Because this launch file is called in the software. You can create an event that when you push a button, okay, you open a software in a PC, for example, let's say a Windows Media Player, and you play a video, okay? So you can just use EclerNet Manager as a bridge between the button and launching a software in a PC. Okay, and the same for this one. This one sends an email, so you can configure the parameters, okay, of server and user and whatever, and send an email whenever it happens something. It has some stimulus, okay. So maybe you have here a signal, and when the signal arrives to some point, it sends an email to somebody just to make an action. Go there to the DJ, say, don't go too loud. Okay. Okay, so we have the next one. The next type of event is a digital delay. Okay, but that basically, as you see, is the same one as we already explained, but with a delay in between the stimulus, the source, and the target. You can add some seconds, some minutes, some days of delay for whatever purpose do you need. That next type of event, digital compound, is called in the software. Okay, basically this is to relate different types of sources, and when this operator, so for example, you want to make an action when GPI1 is active and an event is active and a virtual is pushed. Okay, so to combine these three sources, you get an operator here, which would be a Boolean operator, a logic operator. This would be AND, no? If and this and this and this happens, then make an action. So we can create different combinations of sources in order to activate an event. Okay. And we have also the time schedule. So basically, if you want to make some action at 10 o'clock, 12 o'clock, you can configure on weekends or monthly, whatever you want. Okay. We will see later on a few examples. So presets. Preset is a snapshot of the device settings at the time of saving. It's set. Okay, so you can decide, you save a preset, okay, and you make a snapshot, but you can decide if you want the whole parameters of the device, or maybe just some of them partially store. So I want this routing, but I do not want to recall. Whenever I recall this, I do not want to get the inputs or the outputs. I do not care. So it works as a mask. Okay, if you can recall a preset like this, only the matrix will be changed and the other parameters will remain as they were. Okay, so this is a partial settings. So you can combine events and partial settings, and this opens up a lot of possibilities. It's like artificial intelligence a little bit. If you get concatenate events and make some kind of issues. Let's see some examples. We've got here a folding wall. Okay, a folding wall, because depending on the event, you want independent rooms separated or together, the whole room. So what we will make is, let's think that there's a contact, and when the folding wall is all open, this contact is activated. Okay, so, and this contact is connected is connected directly to the MIMO, let's say the GPI 1, okay? So what will happen that when GPI, I will create an event, a digital event that say when GPI 1 is active, I want to recall this preset just because my configuration of audio is different, and of course I will be using the groups, parallel output groups feature. Okay, so and all the loudspeakers work together as one room. Okay, and I will create another event that will be activated when this contact is open back again, and we'll recall a preset one with the configuration, the parameters configuration of the independent rooms, the separated rooms. Okay. Let's think in another example. Maybe we have here a sensor, okay, movement detection, and we want that when let's think maybe it's a museum, and you want when people go through this sensor, or this sensor detects people, it happens something, okay, but you only want this to be placed, okay, you want this to happen between 8 in the morning and 8 in the afternoon. Okay, so you get GPI 1, you get this sensor, and you create an event. The event will be a digital event, of course, and maybe we want to launch file. Okay, let's think that when you go through this sensor, a message is placed. Okay, we want a message, and this message comes from a PC which has a EclerNet manager, and the PC has an audio output. You can just connect this audio output onto the MIMO. Okay, so see, the GPI 1 is connected to the MIMO and activates an event that launches a player that plays a message. This message gets out of this PC, and this PC is connected to the MIMO. So it's routed to whatever we needed. Yes? Okay. We will have another event that a time scheduled event. So at 8 in the morning, it will start, okay, and because we want this to happen at 8 in the morning. So at 8 in the morning, we will we will load a preset which makes this event 1 active. And at 8 in the evening, we'll create another event, time scheduled event, that will make this preset 2 disabled. This preset 1 enabled or preset 2 disabled, we have to create these 2 presets in advance, and with this option, event remote enabled. So let's see it in an example, okay? We add a device, MIMO 88 in a museum, okay? And we open up, double click here, and we open up the matrix. We get into events, okay, with this button, and we right click here and we add a new event. Okay, this event is enabled by default. We are configuring it, and it's event 1. So we decide, okay, it's connected to GPI 1, and it will launch a file. Okay, this opens up another window and we have to just look for the path of this player. In this case is VLC player, and which file I want to reproduce. In this case, it's a test.mp3 file, which I have in my computer. Okay. Okay, so when I click OK, this creates this event. As you see, in the window of events, I can see the first one listed. Let's create first the two presets. Okay, if I save this, okay, event remote enables. Okay, I have the first preset, and now what I will do is open up this event, okay, and disable it. Say okay. Now, as you see, is in light gray, okay, and I will create another preset, okay, with this configuration. Okay, so now if I add a new event, okay, digital simple at 20 in the evening, I want to recall a preset which will be event1 disable. This is the name of the preset. And we will do the same, but the other way around. So I will create an event at 8 in the morning that will recall a preset which is called event1 enabled. Right? So we've got 3 events. The event that launches the message, the event that activates this first one event, and the third event that deactivates the first event. Well, in fact, it's the other way around. Huh? Sorry, the second event deactivates the first event, and the third event activates the first event. As we want to be active at 8 in the morning, and we want to be deactivated at 8 in the evening. So basically, what happens here is that it will change. Okay, now we are in disabled preset, and if we change to enabled, it will activate or deactivate this event. You see, when it's enabled, when we have event1 enabled preset, okay, this event will launch the file, will open VLC, and will reproduce the test mp3 file. When it's disabled, this is in gray, and it will not happen anything. Okay, so this is, we can, as you see, we can combine, this is a very simple example, but we can combine many different things to create whatever we want. Okay, just here we show the tools, but depending on the installation, you will require some tools, or maybe you don't use it. Okay, so here we've got another section. Okay, let's change to pager and Docker's section. Okay. Let's see, pages and Docker. This section lets you configure an application models, okay, based on the attenuation or muting. Basically, these are the modules that you have to configure to send messages with a paging station, and will, for example, if you have background music on zone 1, okay, and you activate the pager on zone 1, what will happen to the music is it will be attenuated in between this pager is activated, and afterwards the music get back to this output. Okay. Okay, and the same will happen with a Docker. Okay, but with the difference that you don't have a button. A Docker is just it's activated when a threshold is overpassed. Here we have the threshold. So when the signal goes over minus 12 dBs, then it's activated. So the music on that output will go down and will let the dagger signal, which is here assigned, the dagger signal will get into action. Okay, so we've got 4 paging modules in a MIMO 88. In MIMO SG, we've got 3 paging dagger modules, okay? And in MIMO 4040 The End, here, okay. Here, CDN and 7272 The End, so all the ends, basically. We have 25 paging dagger modules, okay? Here we have 23, and we scroll down and we have the other 2, okay? Okay, so here we decide the type, okay? If we want a dagger or a pager, we decide which input is the one that is being used as a pager, or in this case, we have selected dagger, so in this case, will be the dagger. But if we selected pager, will be the microphone input of the pager, okay? If it's PageNet or if it's AEM page, okay? Or if it's another one. Here we assign the priority of the signals. We have 4 priorities in this case because we've got 4 paging dagger modules. If we have more, we have more priorities, okay? And here we select which signals, the destination zone keys, which signals or which outputs are affected by this dagger. So in this case, outputs from 1 to 9 are affected by this dagger. Outputs from 10 to 16 will not be never affected for this dagger, okay? And here's the DAC indicator. So whenever this is in green, as this one, okay, the signal, in this case input 8, is routed to all of these outputs, okay? If it's not over minus 12 dBs, then it's not routed, okay? As routing and not routing depends on the dagger module, you don't have to route the signal manually in the matrix. So in the matrix, you don't have to assign these cross points, okay? If you assign them in the matrix, will be permanently routed, okay? So just let this dagger module take control of these cross points. So you deactivate it, and internally the module will do the job for you. Here we have the several parameters. The threshold we already talked about, and the depth and the attack. Okay, the depth is the termination, the attack, the hold, and the release. Okay, the time to get in, the time to stay on there, and the release. The pager model is almost the same, but we have here the chime, ding dong ding, ding dong dong, and we have also as well the zones the paging station can select to send a message. So in this case, button number 10 will not be, the user will not be able to select it as a zone to send a message. Okay, and we've got 2 function keys to assign to make groups. Okay, in this case, 1, 3, 5, 8, 9 zones will be selected if you select F1. Okay. Okay, to connect this, just here we have the MPage module. the end page is the paging station. So we connect to the remote port in the back of the unit, but we have to connect the audio signal to one of the audio inputs. Okay, so we get the manual. We'll see, and this end page has an RJ45 here. This is the power supply. If you need it, it can be fitted. One paging station can be fitted from the matrix, okay, from the port. So how do we connect this? The RJ45, there are several, as you know, colors. These are the standard colors, or if not, you have to count the pins, okay? And you have to connect the audio signal onto the corresponding input and the control signal to the remote port, okay? Here the remote, we have plus and ground, which is the power supply for the unit, okay? And H and L is directly the port, okay? So just you have to connect this RJ45 to the unit and take care of this wiring to connect correctly the unit, okay? As this unit is also used in other devices, you have to check the jumpers inside. In fact, you don't have to check, you have to change it. By default, they come for other devices configured. So you have to change and put this configuration. All of this information is in the manual. Just I wanted to tell it to you, to explain it to you, just in order that just keep the thought that I have to look it up in the manual when I have to connect it, okay? If you have two EM page, okay, as we have to connect it in daisy chain. Daisy chain is this. From the remote, it goes to the second EM page, okay? From the remote goes to the first EM page, and then from the first EM page goes to the second EM page. Obviously, the audio connection is not daisy chain, is direct to the matrix, okay? So this is as well important, okay? Another thing is that, okay, you can connect several EM page on one port, okay? But remember that maybe you will have to use the power supply, okay? Power supply for a second unit if the distance gets too long, okay? You will for the second unit and the third one and the fourth one, okay? MIMO 88 is up to 4 units. MIMO SG 88 SG or 1212 SG, it's up to 3 units. Remember, you have 3 modules, pager ducking modules, or 4 pager ducking modules, okay? Okay, in the software, we add an EM page. Here in the remote tab, we add an EM page because we want to add a calling station, and we assign it to a pager. In this case, we have configured pager number 1. So we say, okay, it's the pager number 1 module, okay, which we already configured. What about PageNet in MIMO 4040 The End? Okay, you have to connect this and an RJ45 where Dante and control travels in the same network cable. Sorry for that. And you connect to a MIMO 4040 CDN or 7272 DN. Okay. No difference in that from the old MIMO 4040 The End. Remember that you can add a player here. You have two RCAs in the bottom of the unit. Okay. Can I use PageNet for these MIMOs? Okay, the ones that are not the end. Yes, you can use them. Okay, control will be from the network because these are UCPs, but the audio has to travel beside. So you either use Dante and you put a Dante interface in here just to turn the digital audio into analog and get it in one of the inputs, or you use the analog output of the unit to get this audio into the corresponding input. Remember that the UCP buttons have to be pointed correctly. So you have to create the UCP. Okay. In fact, it's already created. Just you have to import it to your project and assign the corresponding button to the corresponding zone. Okay. And creating the correct route. Okay, let's talk about remotes. I think we will make it. Connecting one contact to a GPI. Okay, you have to connect it like that between the 12 volt here and the cursor. So whenever this is closed, you get 12 volt here. If it's open, you do not get any voltage here. Okay, so if we see this in the software, we add an event. Okay, add new. We already seen this, and we select GPI1 as a source. Is GPI1, and we can make these actions, these targets. In this case, input mute, output mute, matrix mute, or activating a GPO, recalling a preset, launching a file, or sending an email. Okay, this is a digital simple event. We are connecting a volume. We connect it this way as well. It's in the manual. Do not worry about this. We'll add a new event, but in this case, it will be an analog event, obviously, because you have the whole range of values. Okay. Here, sorry, GPI1 and volume. Connecting a WPA vol SR. Okay, this is connected like this, but this is a special case as, okay, we usually use this as a selector of the source that we want in a concrete zone, and this is used as a volume adjust. Okay, but we want this to affect to the corresponding cross point, so we don't want to affect to the input because it will affect to all the outputs, and we don't want to affect to the output volume because it would mean that if it's at the minimum, if we send a message from the pager, you will not hear it because the output is at the minimum. So we want to affect to the cross point in the matrix. Okay, so we want to affect into a different cross point depending on what we have selected here. So we should have like a dynamic event, but it's not like that. It's we have to create a remote. Let's see it. We add a remote here, okay, which is remote 2 in this case. Okay, and it says, okay, I want an analog remote because this is an analog remote, and we will have a carousel here. Okay. As you see, there's no other option, so we choose carousel, although I already haven't explained what is a carousel. Okay, so here we have the selector section, okay, and here we have the volume section. If you go to the selector section, okay, selector, GPI3, the carousel, and affects to output 9 in this case, because I have chosen output 9. And GPI4 is the one that it refers to the volume, and we decide this option, which is X focus, because X is depending on what we have selected here, will change one or another. Okay, so what is a carousel? Okay, a carousel is this. Okay, a selection, a list of options. Okay, carousel, you see, you have a white pony, a blue pony, or a pink pony. So depending, you have a selection list for deciding in the selector. Okay, a carousel is a list of selectable options. Where do I found this button? Here, over the events buttons, you found a carousel, okay? And this opens a window. This window where you can create the list of selections. In this case, we have off, so no selection, input 1, input 3, input 5, and input A. So we've got 5 options assigned to this carousel, okay? So if we go back to our remote configuring window, we will have here this carousel. So we will have these 5 choices assigned to this selector. Okay, 5 choices, GPI3. And this is related to output 9. Okay, so depending on, let's see the carousel back again. For example, input 1 is CD player, input 3 is PC mono. Okay, so if I have a selection here of PC mono, okay, what will change if I use this button, this potentiometer? Will change the cross point between the PC mono and output 9. Only that cross point. No other volumes will be affected. So not the output volume. That's the interesting part of this. That's why we have to make a special thing for this kind of remotes. Okay. Keep in mind that all the remotes come for configured for other devices, analog devices. So you will have to change as well the jumpers which you have in these wall panels. Okay, so this is in the manual as well, but just remember, take care of this when you are installing it. What will happen if you do not change the jumpers, it will not work properly. You won't break anything, but you will find that it doesn't work properly, and at first it's very confusing from the software point of view, because you can just go over and over again and you see that you have done it well in the software part, but just because here it's not well configured in the jumpers, you will have some troubles. Okay, so here we have another example for connecting 4 kV this remote that is connected to the network to a MIMO DN. Okay, DN, MIMO DN from now on means 4040 CDN 7272 DN. Okay. Okay, so we add the device here because, attention, because this remote is a device in the network. So we have to add a device, okay? And we choose 4kV and is in the device list, okay? The analog ones are not in the device list because do not belong directly to EclerNet, but to each and every device that is connected to the network. In this case, this remote is not an analog one, it's a digital one, so it's connected directly to the network, so it appears in the device list. Okay. Here you configure the IPs and the network parameters. And in CDN, you go to remotes and you add also here in the matrix a 4kV. Okay. And when you push here, it will open up this. Okay. And basically you relate this remote to a carousel as well and to an output. Okay. And also you will have the choice of changing an X focus volume, an X focus, which is a cross point, depending on the selector. Okay. Can I use this into MIMO SG or MIMO 88? Yes, but you have to make an upgrade of firmware. Okay. And you have to add a remote, and you will see that you will have to choose a virtual remote. There's a manual talking about that, but we will cover it, but not now. We will keep the concept of the virtuals now in a drawer, okay, and we will see it afterwards. Okay, an 8K is just, you can have a carousel of several things, and you will have the option to choose here whatever we want. And you can combine 4kV with 8K and make a 12kV. Okay, this is for MIMO Dante. So you can choose the sources and change the volume. Okay. There's also the multi option. The multi option applies to 4kV and 12kV, that you can just control not only one output, but you can choose to control several outputs. So you can just, okay, one remote is assigned to an output, as we have seen here. But in this multi-option allows to take the role of different remotes. So you can just have one remote for output 1 and the same remote that you can select to control output 2, or you can select to control output 5, okay, whatever you want. This multi-option is available in MIMO DN with 4K and 4kV and 12kV. And WP-Net X can control more things like presets, so sources, selection, and volume as 4kV, but at the same time it can be a preset selector and can control some EQs. Okay, there's no, you cannot use WP-Net X with old or former MIMOs. Cannot be used with MIMO 88 SG or 1212 SG or 88. Okay, this is only for MIMO DN. Okay. Okay, so here you see the window, the configuration window. carousel, sources, mute and volume, equalizer. Okay. Okay. So UCP server. Why we need a UCP server? UCPs are created just for supplying UCPs to other. So we can create UCPs and we use the web server to provide these UCPs not only to the same screen, but also to other devices, which are called UCP web clients. Okay. If you have a Wi-Fi, you can just send them to these devices. Okay. Who can act as a UCP server? WP Touch, PageNet, as we know that it's WP Touch with a microphone and a lot of electronics inside. MyModiN and a PC in deploy mode with the EclerNet manager in deploy mode. So it's you activate the UCP server in the PC. Who can act as a UCP client? WP Touch as well, PageNet as well, a PC with a browser, or Android and Apple devices. Okay. And here's I wanted to explain a way of not getting confused. Okay. When you work with a UCP server, because it's quite confusing at first, and I want to explain you a little story as an example. Okay, you work with a UCP server, but you are working at home with your PC, and you make a project. You make with a EclerNet manager, you make a project. Okay, and here you have your PC. And this is your project. You save it when you're finished at home and you save it in your computer. Okay. Then when you work in local, so with your computer, you will see here your IP address here, and it will say local. If it doesn't appear anything, it means that you are not connected to a network, or you did not select a network interface. Okay, so you will never be able to connect to any device. Okay. Okay, this is an important thing to remember when you are working. So you have your installation. Okay. And you connect to this installation, and you select the interface, and you open up the file. You assign these devices. Okay, and here you want this to be the UCP server, so you enable this UCP server. By default, they are from factory. They are all enabled. Okay, so okay, everything is perfect. Then you connect and you send this file from your PC. When you make this option, okay, I want to show you just okay, connect and send here. Okay, you are sending this this file. Okay, once it's sent, you see it says, okay, I'm acting as a UCP server like if I was the screen. Okay, the WP Touch. Well, this is the name of the WP Touch in this case, and it appears the IP of the WP Touch in this case. Okay, so when you disconnect, okay, it says you want to update, because if you did some changes when you send the file, okay, you can just make some changes on the fly, and you say yes, and then it's sent. It's disconnected. Okay. Okay, so it arrives the night, and the customer was very excited with his panel, and he came and touched everything, but he's missing some features, some buttons, and he calls you. Okay, so now as it's a night and your customer has changed some volumes, some selections, okay, this is not exactly the same file. You have, obviously, mainly it's the same, but some volumes and something that he can change from his panel has been changed. So it's been modified. Okay. So he asks you to go urgently to the installation to add some of the buttons because he don't like. So you go there at night, okay, and you say connect and get. Why connect and get? Because you want this file, okay, this one with these sections. You have this file, but this is a backup file. Let's say you want to use the one that is already in the WP Touch, in the UCP server in this case. So you get this file, you work on it, you make the changes that your customer needs, and once you're finished, first you save a backup file, which you can call version 2, and you say, okay, now I disconnect because I'm finished. And this version 2 file is updated here when I say update yes, and I can go. Okay, so it's the process. What you have in your computer, it's a backup file. Okay, you will use it if you need it, but in order not to get confused, I always recommend to do this. Just you go to the installation, you don't know what happened when you were not there. There's a file that it's supposed to be the same, but and they have changed their parameters. You go there, you connect and get the last modification from the user, so you will not change volumes of zones or whatever. You will save it as version 3 in your file because you have modified some things and you want to keep track of whatever has happened, and then you disconnect and everything is updated. Okay, this is the way to work. We see in the example here, we have the online and unused device list, which are the, okay, let's, oh, wait. So you go here to an installation, we will see this is my own IP address, okay, and we will see the online and unused device list. So they do not belong to any project, okay. So they are in the network and you can see they are online, but they are not used. They are not assigned to any project. If I get these devices and I just drag and drop it here, they will be added. So now they belong to this project. So they are not here in the online and unused device list. Okay. When I say connect and send, okay, and I decide to, in this case, send the this project that I have to the UCP server, okay, then it changes the IP address in here. Now this IP address from my MIMO, so I'm really connected to this UCP server. And when I say disconnect, it says, okay, you want to update. At this moment, it sends the project to the UCP server, in this case, the MIMO 4040, and it disappears from here, okay? Okay, so where is my MIMO 4040? Now, when it's not in here anymore, because it's being used in a project which is in the UCP server of the MIMO 4040. So you will arrive to the installation and you will never see this again, because you have to go and connect again and get, as I said, and get the project from the UCP server. You see? Now there is. Why? Why is not there? Because it's being used. Okay. This list is only for the devices that are not used in any project. And when you arrive to the installation, like this, where is the, when you arrive to the installation, you connect to the network, the MIMO 4040 is being used for a project that is inside the MIMO 4040. That's why you cannot see it. Okay, so if you connect and get again, you receive it. Okay, and can you drag and drop another device, for example, the PageNet? Okay, it's added to the project, and when you disconnect, you update the project, and then all the devices have disappeared. Why? Because they are all being used by this UCP server, MIMO 4040. If I connect, okay, I receive the project, and there we are, both devices. Okay, when you disconnect, you say, okay, I want to operate. Before, I have to save my backup file. Huh? Okay, so that's the way of working. It happens the same with MIMO 4040. Okay, if you open the file that you have inside your laptop, what will happen is this. It will be in red. Why it's in red? Because they do not find the devices, because they are being used by another UCP server. So forget about it. You have always to connect and get. If you really want to use this project in your UCP server, you can connect and send, and you will overwrite whatever you have in the MIMO 4040. Okay, so, and you will override that. So in order not to keep confused, just in one installation, do not get more than one UCP server active. Okay. Okay. So I think we will leave for today this. Okay. We'll make the user control panels design tomorrow. Okay. And some examples as well, which is quite interesting. Okay, let's leave it for now.